guys, and welcome back to this channel. Today I brought something very fancy to you. So we want to prove that the sequence of numbers 1 over 2 to the power of n, where we are adding from n equals to 1 to infinity, is exactly 1. And we don't want to write it down, we want to draw a picture, and the picture intends to prove the statement. So from the picture you see why this infinite sum equals to 1. And you may notice something, because this number here has an absolute value smaller than 1. This whole series is a geometric series. And for geometric series, we already have a formula which allows us to calculate the value. In particular, we know that the series is always convergent if this number has an absolute value smaller than 1. But I digress. Let me show you how we can prove this statement by drawing a picture. And for this, let me draw a square for you. So something like this. It's not so easy on this table here. So something like this. This should be a perfect square. And we assume that both lengths are equal to 1. So this is 1 and this is 1, which means the whole area equals to 1. So area of the square is 1 times 1, which equals just 1. Okay, but we can draw a line and cut the square into 2 halves. Let me do it like this. Again, it's not so easy on my table, but I hope you get it. This is a perfect square and these are all perfect lines. Okay, so by doing this, we know that the area of the first half is just 1.5. But then, what's with the second half? It's also 1/2, right? So we can also cut it down into 2 pieces, like this. And we know that the upper part is equal to 1 over 4. Yeah? And because the lower part is also 1 over, we can cut it again into 2 pieces and get 1 over 8. And then we can continue in the same fashion and get 1 over 16. And then 1 over 32. And you see where it goes, because the sum actually consists of 1 over half as the first addend, then 1 over 4, because 1.5 to the power of 2 is 1 over 4, and 1 over 2 to the power of 3 is, you guess it right, 1 over 8, and then by continuing we are getting 1 over 16, 1 over 32, and so on. So the sequence looks like this, and this is exactly similar to what we have here. And when continuing here with the areas, this one is exactly 1 over 32 again, and then by cutting it down into 2 pieces we get 1 over 64, and then 1 over 128, and the remaining part becomes smaller and smaller, and it's exactly as big as the one we had before, and by cutting it down into 2 pieces it's becoming smaller and smaller, and we are reducing it always by the half of the area we had before. So the next one would be 1 over 256, and then we would have 1 over 512, and so on. And this matches exactly our sum, or our infinite sum here on the left hand side. And as the whole sequence of areas converges against the area of the whole square, the limit of these sequences we are adding together is exactly 1. Yeah, because our assumption was we have this perfect square with side length equals to 1, which means the whole area is 1, and this series we constructed here in our picture is something which converges against the whole area, meaning it's converging against 1, and all of these pieces belong to the terms we have here in our infinite sum. And this proves that this infinite sum is exactly 1, because the sequence of areas which we are adding all together is also converging against 1. So I hope you like this kind of videos. If you are interested in more videos like this, please stay tuned and see you very soon in the next video. Bye bye.